Welcome back to a crash course in circuit theory. In this video, we're going to analyze a single source network and also a multiple source network based on the IV matrix theory. As you recall, we have four options. I have labeled those options A, B, C, and D for easy reference. A and B representing the voltage characteristics, C and D representing the current characteristics. First, let's talk about the single source network. I've drawn two diagrams here. One diagram represents me using a voltmeter to measure the voltage at Vx, and the second diagram, me inserting an ammeter to measure the current through the point, Ix. You will recognize that this is the same series circuit that we've always been using to represent basic electrical theory, consisting of an energy source as well as control elements and our corresponding load. Our load being represented by a simple lamp. I've drawn two boxes, one box around the energy source and another box around the load and control components. And I'm interested in understanding what happens at the terminal between those two boxes. Well, the energy source over here is a variable energy source. So the energy source will control the level of the voltage at that point. So whatever I set for the energy source, for example 5 volts, then that's the voltage I will read from Vx to ground. If I increase it to 10 volts, then my voltmeter will read 10 volts and so on. So you can see in this diagram the energy source is directly controlling the value of the terminal Vx. Even if I alter the components in the control network, the terminal voltage will still be fully controlled by the energy source. Now moving on to the second diagram. The second diagram, I'm showing the current. One thing you should observe is that since we're only using a single source, there's only one possible direction for the energy, and that is out, which means that the current will always be flowing out of the energy source into the second box and returning back to the negative terminal of this energy source. So we only have option C in this example, where the current will flow out of box number 1, so it acts as a source, and into box number 2, which acts as a sink for the current. And that's the nature of a single source network, because from circuit theory, current flows from the positive towards and back to the negative. So there's only one possible direction for the current. Of course, the value of the current can change based on the settings for the energy source, whether I set it to 5 volts, 10 volts, or 24 volts. But still, the direction of the current will still be in this pattern, coming out of the positive terminal and back into the negative terminal. So to review once again, for a single source network, I have both option A and B, which means I can increase or decrease the value of the voltage based on the setting of the source. If I did analyze other terminals, then the control elements would have an effect on the value of the voltage. But still the voltage could either be increased or decreased depending upon the position of the switch or the position of the potentiometer. However, if we analyze the current, we will see that the current will only flow in one direction. Of course, the value of that current will be determined by the status of the energy source and the position of our other components. But we can conclude that we only have option C here, and that is one direction. In the next video, we will analyze the multiple source, and you will begin to understand how complex electrical circuits can become when you start adding more than one energy source to the analysis. Thank you.